So now we're going to switch to our integration questions. So here we have an integration question. And whenever I get an integration question like this, I always want to start with u substitution. So I want to see, okay, can I do u substitution? And here, when we're looking at it, it's like, okay, yeah, this here looks like it's the most contained function. So it's the most internal piece. So this means that I would make u equaling to sine x cubed. Well, that means that my du by dx is equal to 3x squared sine x cubed. And now I'm going to create my rational expression, 3x squared sine x cubed du by dx is equal to 1. And now I'm going to multiply it in. Oh, I have made a mistake with my derivative. This should be cos x cubed e to the sine x cubed multiplying by 1 over 3x squared cos x cubed du by dx. I'm going to do some simplification. This equals the integral of 1 over 3 e to the sine x cubed du by dx, which equals the integral from 1/3 e to the u du by dx. The antiderivative of e to the u with respect to u is just e to the u, so I get 1/3 e to the u plus c, which is going to be equal to e to the sine x cubed over 3 plus c. And now we have b4, or b7, which is going to be the integral of x squared ln x. So I'm looking at x squared ln of x with respect to x. Here, I'm looking at it and going, antiderivatives of lns are annoying. So does the ln come from anywhere? And if it does, great, but it doesn't look to really come from anywhere. And there's nothing looks like it's inside or outside. So here we had this inside function and outside function, and there was an obvious, like, this u substitution might help us, and let's go with it, see what happens. But here there isn't really anything like that. So my brain goes, oh, I have a product of the things, maybe u substitution, or maybe integration by parts will work. So I'm going to have u and dv. And now here, remember, we want to get rid of something that we either can't derive, like ln. We can't take the derivative of ln. Or we're going to take the antiderivative of something that sticks around. But nothing really sticks around. So that ln being my u that to me makes most sense. So I'm going to try doing ln u equals ln of x. And that means my dv equals 2 is x squared. And the nice thing about it being x squared is x squared, we can take its antiderivative nicely. So we don't have to set it equal to v and figure out what dv is. We're more than happy to just let dv be x squared. And now we take the antiderivative of x squared to get x cubed over 3. And the antiderivative of ln of x to be, or the derivative of ln of x to be 1 over x dx's. And now we take our I like to say alligator, but we just apply our integration by parts rule. So this is x cubed over 3 ln x minus the integral of 1 over x times x cubed over 3 dx, which is equal to x cubed over 3 ln of x minus the integral of x squared over 3 dx, which is going to give us x cubed over 3 ln x minus x cubed over 9 plus c.